Hello everyone, welcome back to our channel. And the last time we built the circuit with this. This is a Night Rider and LED chaser Night Rider using 555 and a 4017 IC. And also we have this previous circuit. This is LED blinker 4017. The one that is providing the clock is the ordinary LED blinker to the 4017, making this a random effect of LED chasing. We also have this, that is 555 timer 4017 IC. This is also an LED chaser blowing in one direction. Also, we have this kind of LED chaser using only a 4017 with a push button here. This is a manual LED chaser. By pressing the button, we can have this LED chasing. All of the four circuits are using 4017. So we have that, the Night Rider, the LED chaser using ordinary LED chaser and 555 timer, and this one is the Johnson counter. Now let us make another LED chaser using 74HC595 IC, a shift register 8-bit. This is the IC. (16 pins), and we have this 74595 module. We have the IC 74595, the headers female 3, some capacitor here, resistor, LED, another LED, resistors, push buttons. This is a shift register module. We also have here LED module. This is LED, 8 LEDs, 5mm in size, connected in parallel with the male header. This is an output LED. And these are input LEDs, and this LED is power on LED. So let us connect. Then the power to the back, the header with 5 volts supply. Let us check. Okay, it's working. We have this push button. This button is a data pin button. This one, clock button. This is latch button. This one is reset. And there's a light, normally active high. And this one, output enable button. So we got 5 buttons here. Let us see. Check. Every time you press the button, input LED turns on. This one turns off and on, little dim. Also this one. So pushing the data button, and then the hold, and then the clock. We have again pushing the data. We have this, an LED chaser. Clearing. This is a reset button. Let us reset that with the latch. Again, there's no output. Let us try again. Data, hold, clock, release, data. We don't have. Okay, let's clear the register. The input, the memory of the register. Let us clear all the output. Also reset. Let us check. Again, let us try. Data, clock, data button. Okay, clear again. The difference with this one, with what we have here, this is the only manual counter. This is a shift register. We have this manual counter using port 017 is when you press the button here, LED tend to shift from right to left. Just like that one. That one is an automatic counter because the clock is provided by the 555 timer that serves as the clock here. The clock here is provided by the push button. But in here, only I press one clock at a time, and the data pin is now the one providing the lights to the LED. So let us begin again. Data, clock, we have the light, then data pin. Again, let's clear. Okay, reset. Again. See that? Again, data, hold, press, clock, then release, data again, release, data, press, release. Again, we don't have. That is the difference with the Johnson counter. Did you see the difference? So we have here one input and 8 outputs. You can control 8 outputs in just one input here, a data pin, data button. So let us see. This is the power on LED, input LED, data button, clock, latch, reset, output enable. So the output enable button is It's used to turn off the output LED. Just release, press release. Let us see the circuit diagram. We have here our circuit diagram. We have the 5-volt supply here, a voltage stabilizer capacitor. Also we have this power on LED, and then we have a lot of switches, push button connected to the IC 74595 SN74HC595. So in here, in pin number 14, that is the data button. Also we have the switch here, and then the LED. Pin number 13, that is output enable. 13 also have a switch, and we have this a switch for switch debouncing capacitor. This is in data pin. We have here electrolytic capacitor of 1 microfarad. But here in the OE pin number 13, we have only 104 ceramics capacitor. Pin number 12, that is the latch clock or the latch. We have this 104 capacitor, and then also a resistor in series with LED. Shift clock or clock, pin number 11. Also we have this 104 capacitor in series with the resistor LED. In the reset button, it is held high because we're going, once you press the button here, the memory, the register clears all the memory or the input data inside the register. Once you press the button here, current flows directly to the ground, short-circuiting the current flows instead of here in the IC. So it clears all the memory. We also debounce capacitor here. Also pin number 8 ground. Pin number 15 is 16. That is the power supply of the IC. We have the outputs here. 15, 1, 2, 3, 4, 5, 6, 7 output to the LED in series with the resistor. All the values of resistor here is 330 ohms each. So this is the least significant bit. This pin 1. I mean pin 15. And the most significant bit here is 7. So the LED shifting from this LSB to here, to here, to here, up to pin number 7. The value of the pull-up resistor here connected to the reset button is 1 kilo ohms. The other one, this R6, is 10 kilo ohms. Just providing a nice voltage divider to the IC. Once you press the button here, current flows to the push button, clearing all the input inside the register and debounced by the switch, by the capacitor. Once you press the data here, press the button, flows to the ground, input LED turns on, and of course debouncing the switch. This is electrolytic capacitor, and I put also in the clock electrolytic capacitor also. Value of 1 microfarad, 16 volts. The rest of the capacitors are ceramic 104. And then we have here all the values of resistor. Here is 330 ohms, except this one, 10 kilo ohms for the R6 reset, and 1 kilo ohms pull up. So that's the block diagram, or I mean the schematic diagram. I use this capacitor for voltage stabilizer, for stabilizing the circuit. And we have now here a circuit diagram with the values: 10 microfarad, 330 ohms. Connected here is the actual pin out of the IC. Then I have the switches, the push button, the capacitor, the values of resistor from R2 to R5, and I connect it to the header. So that is now the actual PCB layout of this header. The two header. Left side, power supply. I mean the supply also. Here also power supply that is connected at the behind the module. So this is a shift register module. These are the components, the IC, PCB layout, the header, and this one is the LED output module that is connected here at the male header. The LED is in series with the resistor. All LEDs are connected in parallel. So we get here now the ground. So when you connect this module to here, since this is also ground, then the power is here. We got now the output power of the LED. And this header is now connected to the header of the output. 1, 2, 3, 5, 7, 8 connected here. So this is now our new circuit. That's why we have this type of LED chaser. The difference is from Johnson counter, it has a steady light. Unlike the Johnson counter, once you press the button, so let us begin. See, when you press the button here, LED shifts to the left by 1. But here, when you press the data button, stays turn on. But this one, the other one's turn off and turn on. Again, pushing it to the third LED, pushing the data button here, so it changes. But here, so you're controlling 8 outputs with just 1 input. In here it's different. You have to control it only one by one, only once. That is now the new LED chaser module using shift register 8-bit 74HC595 IC. So it took me 1 week to build this circuit because I have a lot of research, and we can continue building another circuit like this using the IC in the near future. So stay tuned to our channel for more video like this. Okay, thank you for watching. Bye bye.